Okay guys, so in this video we are going to make a deep dive into JavaScript promises, so let's get into it. We will cover what is a promise, why is it important, and well, actually quite a few examples of how to use promises. So let's get into it. Now, a promise is just a object that allows you to express what you want to happen with an async operation once it is finished or when it fails. Now, usually you will see people use a promise chain where you see a .then call or a .catch call and so forth, and this will all make sense in just a moment, but just keep this with you that async operations are things such as set timeout or something like a time interval or a network request or something like that, something that is asynchronous. All right, good. So the reason why promises are important is because they allow us to get away from what we call callback hell, where usually, like in the back in the day, what you would do is that you would make, say, an Ajax call to an endpoint, and then you would get a response, and then maybe you needed to do another Ajax call after that, and then you would create another Ajax call inside of that callback, and then that would have a callback, and maybe a third Ajax call, and so on and so on and so on, which would get really, really messy. So what promises allows you to do is to make your code a lot cleaner. So the way we're going to approach this is using the test framework called Jest, and I'll show you a bunch of different tests that I've written, and we'll walk through those. I just wanted to show you so that we get this out of the way first and foremost, that all of these tests are passing, so all the code that you're going to see is going to work. So we got that out of the way. First things first, I'll just scroll very briefly through all of the code that I'm going to show you, so that those of you who don't want to sit here and watch the whole video, you can just kind of pause the video here and look at the different code examples if you want to, and just skip all my nonsense talking. And for the rest of you, let's get into it. Now, first and foremost, this is the traditional way that you will instantiate a resolved promise. So basically, a promise can exist in three states at any given moment. A promise can be in the pending state, it can be in the resolved state, or it can be in the rejected state. You will see different behaviors depending on which state you find yourself in. So let's say that when you make, say, a network call using Ajax, then the promise that is returned to you is going to be in the pending state. And the way that you do you start chaining things is that you express with using the .then function on the return promise. You express that, all right, when the promise is resolved, do this, and then you can actually just keep on chaining. As long as the promise is resolved, you can keep on calling .then basically. If the promise gets rejected, something goes wrong, then the catch function is the function that's going to be invoked. Now all of this is going to make more sense in just a moment, but just keep that with you, so that this global promise object, you have a resolve and a reject function, which is it's just convenience methods for you to express that, okay, I want to create a promise that is resolved, or I want to create a promise that is rejected. And as I said, .then is the function that's going to be called if the promise is resolved, and otherwise it's going to be a rejected promise that's going to be called with the .catch. That's basically it. And the done function here, what that is basically, this is just way of saying that, all right, you have some asynchronous code here, and this function here, can you please call that when that async code is done, basically, so that the test knows when it's finished, basically. If you don't call the done function, you're going to the test is just going to time out because it doesn't know when to stop. That's basically what's happening here. Now you can of course also use the async keyword, which is this thing here, which is a fairly new thing in ES6. So you declare an async function, then you don't need the done callback. And what's happening here is that I create a resolved promise, and then I wait for it. I call .then, and inside of that function I return the value 1. So actual here is going to be 1, and as you can see on my assertion here, actual is going to equal 1. You can do this with the reject as well. So I do a wait, I create a rejected promise, and then I catch it, I return 1, and then it passes. And you can also do something you should be aware of. Let's say that you don't want to do the catch, for example. You simply want to do like more traditional synchronous looking code. You can do a try catch where you basically create a rejected promise with an await. Now this only is this is only applicable if you use the async keyword here, of course. But what's happening now is that I create a rejected promise. And when you create a rejected promise with the await keyword, it's going to throw an error basically, and then you can grab that in a try catch, which is going to return the value. And our expected value here is 1. As you can see that since the tests are passing, I just wanted to illustrate with this throw here that what's going to happen is that this line is never going to be executed because this promise rejection here is going to be thrown, and the value that we are receiving is actually 1. And as you saw earlier, the tests are passing, so this is actually what's happening, right? Just a little bit of like insight into the differences between using traditional promises versus using promises with async await. Okay, let's move on. You can return a resolved promise inside of another promise. So you can see here that I create a resolved promise, and then I create another promise inside of that promise, and then I grab the value, which is going to be 1, and then finally I just call done. Simple. You can create, you don't have to return just a value inside of another promise. You can create a promise inside of a promise, and it's still going to return a new promise. You can nest them as much as you want, actually. You can do this with a rejected promise as well, but remember that once you reject something, it's going to be the first catch function that is going to be invoked. So you can see there at I create a rejected promise, and then I catch the rejected promise, I return another promise that is resolved, and then I call the then functions. So you can just keep on chaining here. So one thing that I see a lot of people do as well, which is not that great, is that you do nested like you create these types of nested promises. Try to avoid this pattern where you create a promise and then inside of that promise you create another one and then you nest another one. Just avoid that. Do this instead, which is what you saw kind of earlier, that you create a promise and then you simply keep on chaining them through and through like this. Try to keep it as flat as possible so you don't get this code belly that or this slope on your code. Because if you're doing this, then you might as well do like the callback structure that we've seen in traditional software, like in traditional code where you do asynchronous stuff, right? So promises are designed to get you away from this. So try to favor this chaining method instead. So the way that I think about promises is that it's just a pipeline of things or transforms that are happening. So the way that I couldn't really find an awesome way to illustrate this, but I hope this is good enough. So we have a value of 1 that is in a resolved promise. Basically, you get the value, you convert that to an object with a foo, and then in the next step you simply create a new object that grabs the first object and adds 1 to that foo, and then you create a bar object that adds 1 to foo. We grab the bar property in step 4 here, and then we convert that to a string, and then for no reason whatsoever we convert that to an int. We grab that value, we create a count of 0, and then we loop over that count and increment it by whatever, like the value of that we're being passed, basically, and then we return that value, and then we expect that value to be 3, and then finally we are done. So this little contrived example is just to illustrate you that all you're doing is that you're creating a chain of asynchronous code that is going to be executed one after each other. So just think of a promise chain as a series of steps that are going to be executed one after the other. And if we think about how map works, that's actually exactly like, if you notice here, this is almost the same code. This is basically what the promise is. It's just a series of different conversions from one thing to another. And then we add this reduce here at the end just to extract the value, because map works on arrays instead. But that's what I want you to take away from this. A promise chain is basically just a chain of maps. That's a very good mental image to keep with you. So another thing that confuses a lot of people is that promises are just objects. So what I'm doing here is I'm creating a resolved promise that is going to contain the value 1. But once I have created that promise, I can actually use it in any way I want. So now I can create another promise. So this one here, I'm awaiting promise.then, and then I just add 1 to that value. And in another promise, I simply add 2 to that value. And now I have 2 different values derived from the same promise. So a promise is just an object. Just keep that with you. It's an object that is containing a synchronous operation that you can chain on and just tell the promise to do something once it's resolved. That's it. And if you reject a promise, you're going to skip all of the then calls until you reach a catch. So here we have a rejected promise, which means that we're going to skip all these .then chains and simply go straight for this catch clause here. So that's a good thing to remember, that all the thens are skipped until you hit a catch if the promise is rejected for whatever reason. If it's resolved, you're going to pass through all of the then clauses until you have a rejected promise. I mean, if like step 2 here, if we returned a rejected promise from this method, we would skip step 3 and go directly to the catch. So that's a good mental rule to have for yourself. If something goes wrong in a promise chain, you're going to find yourself executing the first catch clause. All right. So if you reject a promise, you can recover in the catch as well. So here we have a rejected promise, and all we're doing now is that what's going to happen is that we're going to skip the first step. We're going to go to the catch, and then we are going to add another then, because we can keep on chaining now all the way down. So if you have a catch, that's what happens here is that we reject the promise, we skip the first then, we hit the catch, which is going to return another promise, and then we keep on going. That's basically how it works. Like, you could in theory create another issue or return a rejected promise here as well, and then you would hit the next, then all of this would be skipped until you hit a catch clause, or until you hit, if the promise doesn't find a catch clause for a rejected promise, it's going to throw an exception, which is like unhandled rejected promise or something like that. That's basically how it works. So it can get a little bit crazy, and it's actually a bit of an anti-pattern to do this. So you reject a promise, we're going to skip the first then, we're going to hit the first catch, and then we keep on going, and then there's another catch, and then there's a then, and then it's finally done. Like, I'm just showing you this example to kind of illustrate that. Try to keep this chaining as simple as possible. Ideally, you just want one catch to handle the error case, and then you kind of bail out. There are exceptions to this, but it gets really tricky if you do like this sort of complicated nesting structure where you try to save yourself from a catch and then keep on chaining and stuff like that. Just good rule of thumb, keep it simple. So then we have this old school way of doing asynchronous code. So we have this function called wait for it, which is just going to take a time and a callback, and then it's going to do a timeout and call the callback with the value 1 for amount of time. And as you can see here, we simply add 0, so we're not going to wait. We're going to wait for 0 seconds just to produce the asynchronous code. And then we're going to get a value, and we expect that value to be 1, and then we call done. And like, this is a traditional callback function. Now, the way that you would convert a traditional callback function to a promise-based system where you have like a synchronous code is to do something like this, where you will simply create a new promise that takes a function that has a resolve function and a reject function. And the way that this works is that if you call this promise, whatever code is inside of the promise, if you call resolve and return something there, what's going to happen is that that value is going to be passed to the next .then function in the chain. If you call reject, it's going to skip all the .then functions and go straight to the first catch function it can find. So that's how it works. Resolve means go to the next .then, reject means go to the next .catch. I hope that makes sense to you. And the same thing goes for, as I said, rejection. So what's happening here is that you basically say that, hey, can't promise, go to the next .catch function. So as you can see here, we're using the async pattern, and the way that async works is that basic, as I said earlier, like you can do this with a try-catch structure, and this is like ideally if you're using ES6, you should be doing this instead of using like .then .catch. It gets much cleaner. So what you want to do here is that if you have a promise and you use the async await system, you simply await the promise based or the asynchronous function. You grab the value and then you wrap that in a try catch, because if the promise is rejected, which is what's happening here, we are using the reject here. So what this is going to do is that this is going to throw a error, which is going to be catched here with the value, and we're going to simply get that value. That's all there is to it. Like we call reject with that value, and that's the value that's going to be passed in here. And I just wanted to add this throw new error line here on 231 to just illustrate that this code is actually never run, because we are stopping here. This is going to throw an error, and it's going to be, well, not an error, but this is going to throw that value, and it's going to be catched here and passed into this part of the function. That's basically how it works. So try to favor using async await and try catching instead of doing promise chaining if you can. And then we have the old school way of rejecting, which is probably what you're accustomed to if you're coming from, like, if you've been working for a little while. So here, instead of using the try catch, we simply do wait for it, catch, we get the value, and then we execute basically the same function. Like, these two functions here are equivalent, or rather these two tests are equivalent. It's just that this one is using async await, and this is doing it in the traditional style. And then we can have nested promise structures, which is really ugly, where you have, once again, I see people do this fairly often, where you create a promise, and then inside of that promise you create another promise, and then you resolve that. Like, this gets really messy. And like, ideally, you have to try to remember that you have a chain here. So let's say that you have two asynchronous operations that are happening inside of the same function body. Then you should probably think about doing something like this. You create one nesting, as you see here, and then you can do this. Remember that you can simply return a promise here, and then you can chain on it and use .then. There's no reason for you to nest two promises like this unless you're really sure of what you're doing. So try to favor this approach instead. Or even better, you can use promisify, like this new promise structure here. I mean, there are situations where you absolutely want to do this, but in the more recent versions of Node.js, there's something called promisify that makes all of this a little bit easier. So let's look at a cleaner way to do the same thing, because what's happening here is what's happening here, but it's just that you save yourself the hassle of having to write that code yourself. So here we have this promise wait for it function that takes a value and a callback. And the way it works is that the interface that is required for promisifying something is that the function has to end with a callback function that follows the Node standard callback function system. And the standard way is that it expects that there is a function at the end, like the last parameter is a function that will take two inputs, which is going to be, the first value is going to be an error, and the second value is going to be the value that you expect to be returned from the callback. And since we're passing in null into this callback, that means that there's not an error. Had there been an error, we would have passed it in there. But this is a function that can only succeed. But if there was an error case, we would have passed it in this slot here. So what now happens is that we can use the utility library and use promisify on this wait for it function. So what this traditional callback function is now going to do is it's going to get converted into a promise based function, which is this promise me function. So now we can call promise me with 1 and start chaining as we would have with any other promise based function. And this works for async await as well. So we create a promisified wait for it function, and then we await, and then we do our assertions. It's that simple. So promisify is a very nice way to skip all of this boilerplate new promise yada 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 stuff. So promisify it's pretty great. And let's see here. Yeah, we've already walked through all of this stuff, right? You can promise that with this and handle an error. Yeah, okay, so yeah, this is just an illustration of the same thing you saw earlier. So what's happening here is that you remember I was saying that the interface is that the callback function that this traditional callback function needs, like that this traditional way of working has to, like the interface is that the last function needs to take two values, and if you pass something into the first part of the function, that is going to be the thing that you're passing into the error case, and this is going to be the thing that you pass into the success case. So if there is a truthy value passed into the first slot of the callback, that means that something went wrong. So what this function here is always going to throw an error. Ideally, this shouldn't be a value, it should just be like new. Let's see if I can type here. Error, foo, something like that. But anywho, so what's happening here is that once you promisify this function and create this new function, you can do the await, and this is always now going to throw an error. This value that is returned here is never returning something. It's throwing an error, which is going to be put into the catch clause here, which is going to be this value. And it's going to just, yeah, it's going to be 1. So what's happening here basically is that this 1 that we're passing into the promise me function, as you can see in the body here, we're taking the value, we're plugging it into our error case here, and that's the value that's coming out here. Gets a little bit tricky, I know, but that's the way it works. Anywho, it's not a good idea to handle errors inside a function, to handle errors inside a function. So basically, what I see a lot of people doing is this thing here. So you have this function, myFailing function. It rejects a promise, and then you do a catch inside of that promise. Don't do this, because this is one of the most common reasons why I see people kind of get messed up by promises. It's much better for you to simply return the promise. Like, just do whatever asynchronous operation your function needs to be doing and return the promise, because what you want is to do this. You want the caller to decide what's going to happen when you reject the promise, because usually what I see is that people create this like internal catch clause, and they maybe do some logging or something like that. And the problem is that if the caller then does their own logging, or they start chaining, keep on chaining, because remember, even if you create a catch, you can keep on chaining as long as the promise is returned. Whoever's calling myFailing function, well, they can keep on chaining on .thens and just keep on going, and they have no idea, without reading the implementation of this function, that there was a catch inside of this function. So ideally, just skip that and just return the rejected promise, and let the person who is calling, or like the code that is calling that function, deal with it, as you can see like what's happening here. Great. It's just a good rule of thumb to just have that in mind. If you're creating a promise inside of another function, just return the promise. Don't do .catch inside of that promise unless you plan on like handling it and then doing a .then and returning whatever function or whatever promise is going to be created after that. Just a good rule of thumb. And then another classic case is that you have multiple promises which you want to resolve at the same time. Maybe you have 2 asynchronous network calls or something like that. You want to do multiple promises at the same time. So we create 2 promises here, put them in an array, and then we can do promise.all to resolve all of the promises. What this basically means is that, hey, wait until all promises are resolved and then give me back an array of all of those promises, which is these values here. And then all we're doing is we're concatenating, like we're adding those values together, and we expect that value to be 2. That's it. But what you should be aware of here is that when you do promise.all, if any of the promises fail, if you have 100 promises and 99 of them resolve and 1 fails, all of them are going to fail. All of them. So what happens here is that we have 1 rejected and 1 resolved. Now we expect the value to be 1, because when we do promise.all, we have to put a catch, because 1 promise is rejected, and that's going to be rejected with the value of 1, which is going to be this value. Then we return that value, and as you can see, our assertion is correct. And since our tests are passing, we know that this value is now 1. So it can be a nice thing to unwrap promises, for example. This is something that I think I do this quite often. Maybe like if you have, say, a bunch of network calls where you just want to have an array of a bunch of values that are coming from some async operation, that's one case where this is a very nice pattern. But sometimes you have like you want to do multiple network calls at the same time, and then you just want to extract each value as you kind of go along and do something on each individual value. Maybe you have different types of data. Maybe you need to get a user, but you also need to get a friend of that user at the same time or something like that. Then what's very nice is that you can do this, that you can create two promises that do some asynchronous operation, put them in the promises array, await all of the promises, and then you can use destructuring to simply extract these values and keep on working with them as individuals instead of doing what we saw earlier here where you treat them all as an array. I think this is a very useful pattern to use. I use it quite a lot. Another tip I can give you is that sometimes you want to work with, like what you want is to be able to do a bunch of network calls or asynchronous operations, and you just want to deal with the things that work. Maybe you have some bunch of stuff that you want to do and you don't care about the failures, you just want to get the successes or the successful promises. So what you can do then is that you can do a bunch of like async operations. You can create a bunch of promises, add them to an array, and then create a values array like this. And then you can loop over them, and using the async await pattern, which you can actually just await each promise, and if it works, you simply push it to your values. If it, otherwise you catch the error. Like either you handle the error or you do what I do here, which is just ignore it. And with this looping pattern, what you can do is that you can just save all the successful promises and simply do whatever you want with those promises. And then we have racing. So promise.race, what that it does is basically that it takes a bunch of promises and it will simply get the first promise that is resolved. Now, since these are not, like, usually what happens is that you do a network request or something like that, and some network requests are slow and some are fast, and you're simply going to get back the first network request that is resolved. That's basically how it works. But since we have two resolved promises here, and we create promise 1 and promise 2, and we just put them into that order, promise 1 is always going to win because it's like these promises are resolved instantaneously. But if we switch order on promise 2 and promise 1, promise 2 is going to be the thing that is going to be returned to value. That's basically how it works. But the promise, like the racing situation is the same for as in the promise.all situation. So if you're racing a bunch of promises, if any of them fail, you're going to just have to deal with that. So it's something to remember that promise.race and promise.all expects all the promises to be resolved. If any of them fail, you're going to be faced with having to deal with the catch clause and the whole operation fails. And you can do, as you saw earlier here, you can simply apply the same mentality that you can, if you want to deal with just the first failure or the first success case, you can do something like this. Let's say that we have two rejected promises and one resolved promise. We add them all to an array, and then we loop over all of them. And then we simply check if there is a single successful promise. We simply keep on looping. Then if there's not, we're just going to await the first promise, and we're going to push that value to, or the resolved promise value, to our values array, and then we're going to keep on looping. What this code basically does is that it's just going to keep on looping until it finds a promise that is successful, and then we're going to then we're going to be done. That's it. So this code here is, it's also very nice if you have maybe a bunch of network calls and you just want to get the first one that is successful. This is basically the same thing that racing is doing, but instead of failing if there's a single failed asynchronous operation, you simply attempt over and over until you find the first successful one, and then you're done. So these are, this is like a very rapid walkthrough of the different types of like situations where promises are useful and how I very commonly use promises. And I could make this much more elaborate, but I think that this is good enough. I bombarded you with a bunch of information, and I hope you found some of this useful. There's tons of more stuff that you can learn about promises, but this should have given you most of what you need to know about promises to understand how powerful they are, and some of the situations where you can like apply different mindsets for using promises. I hope this was useful to you. Have a great day.